Hello everyone and welcome back to course of engineering mechanics. Today we will go for third problem of parallel force system. Now let us first understand what is given in the problem. So in the problem a 25 Newton of force is given which is acting at point B in a beam ABC where AB is equal to 2 meters and BC is equal to 3 meters and this force is of 25 Newton. So what we have to do? So first we have to replace, or we can say resolve, the 25 Newton of force in a force couple system at A. So we have to replace this 25 Newton of force such that one force and one couple, or we can say one force and one moment, will appear at point A. So this is our original system. This is our original system. Same thing I have copy pasted over here. Okay, and here I'll draw a new system. So now in new system, say this is AB and this is AC and this is point B, and what I want, so I want first a force at point A. So here I have drawn a downward force at point A. Downward is direction what I have assumed. Let me call it as R. Okay, and a couple at A. So force and a couple at A. Here again I have to assume, let us say moment, what I am assuming is a anti-clockwise, and to that I'll call M. Okay, so what I have done, I have removed this 25 Newton of force, and instead of this 25 Newton of force I am applying one force of magnitude R at point A and one moment at point A without changing the overall effect, because they are saying resolve. What is meaning of resolve? So your end effect should not change. Whatever effect is produced by this system, same effect should be produced by new system. So can I say these two systems are equal? These two systems are producing same effect. Let us first start with the resultant. When I am saying that these two systems are producing same effect, can I say that summation of force in original system is equal to summation of force in new system? So whatever total forces are acting in original system must be equal to the total forces acting on the new system. With that, can I say first is for original 25 Newton, so I'll say minus 25 Newton, because here again I'm assuming downward forces are negative. Okay, and here I'm getting, here you can see in original system there is only one force, so 25 equal to, in new system there is again one force, that is what, R. So I'll say what, minus R, because I have assumed that R is acting in downward direction. With that I'll get value of R as 25 Newton, right? And what direction I have assumed is downward. When I'm getting answer as positive, my assumption is right, and hence 25 Newton of downward force, my assumption what I have assumed is right. So out of this resultant force and a moment, I got value of resultant, that is equal to 25 Newton. Next is I have to find magnitude of this moment. So again first I have started with what, assumption, and I am assuming that moment is in what, anti-clockwise direction. Let us see whether what I have assumed is right or wrong. So here I will apply same thing, summation of moment of original system is equal to summation of moment of new system. Whatever moment is produced within this force, all the moment must be equal to the total moment produced within this force. So we'll start from here. First there is a 25 Newton of force and that will produce some moment. What is the formula for moment? It is force into perpendicular distance. Perpendicular distance between force and point about which I am taking moment. Say I am taking moment about point A, then this length, okay, this length is given as how much, 2 meters. So 25 into 2. Now it is producing moment in which direction? So it is producing moment in clockwise direction. Put minus sign for the clockwise. For this we have to assume that anti-clockwise is positive, so clockwise will be negative. Is equal to, we'll go for now new system. In new system you can see there are two things. First is resultant force and next is a moment. First let me copy paste the moment, so I'll say M. Okay, I am not putting negative sign over here because I have assumed that M is in anti-clockwise direction and anti-clockwise is taken as positive. Next is force R, and we know very well that forces that are passing through the point about which I am taking moment will give me what? Zero moment, because R और A के बीच में जो horizontal distance है वो zero है, तो R into zero will give me answer as zero. So total moment will be produced by R will be what? Zero. With this, can I say that M is equal to minus 50 Newton meter? Force is given in Newton and distance is given in meter, then M is equal to minus 50 Newton meter. Here, minus sign indicates that my assumption is wrong. I have assumed it in what? Anti-clockwise direction. So now I'll correct it and I'll say M is equal to 50 Newton meter in clockwise direction, and that's the right answer. So that's how you have to resolve the force. Now here three cases are given, so we have solved case 1. Now we will go for case 2. Now in case 2, same thing, that 25 Newton of force we have to resolve, but this time we have to resolve in it force and a couple system at point C. So as you can see here that at point C, one downward force is acting, to that I am calling it as R, and one moment is produced. This moment I have assumed in, this time I have assumed in anti-clockwise direction, and to that I am calling it as M. Okay. Now to avoid this confusion for this R and M, you can call this as RA, you can call this as MA, you can call this as RC, you can call this as MC. So resultant at C and moment at C. Okay. Now again we have resolved this 25 Newton into a force and a couple system at A. Then I can say that these two systems are producing same effect. With this I'll say summation of force of original system is equal to summation of force of new system. That implies that here I'll say minus 25 is equal to minus RC, and therefore I can say that RC is equal to 25 Newton. Since I'm this minus will get cancelled out and I'm getting answer as positive, I'll say whatever direction I have assumed is correct. Okay, so this I have calculated value of RC. Next we will go for moment at C. So that is couple at C. Again, summation of moment of original system is equal to summation of moment of new system. Let us see what is a moment produced by original system. So first is this 25 Newton of force, then I'll write force. Moment is nothing but force into perpendicular distance. Since force is vertical, its perpendicular distance will be this horizontal distance, that is distance between force and a point about which I am taking moment. Okay, because I have to replace resultant and force at C. Okay, so when they are asking for A, I have taken moment about A. Now they are asking for C, so I am taking moment about point C. Okay, so that distance is given to me as 3 meters, so 25 into 3, and this will produce moment in anti-clockwise direction, so we'll put plus sign over here, is equal to, again RC is passing through point C, then it will produce zero moment, then only left is what? MC, that is moment at C. Okay, again I have assumed this in anti-clockwise direction, so we'll put it positive. Then I can say that moment about C will give me answer as 75 Newton meter this time, but this time I am getting answer as plus 75 Newton meter. That indicates that whatever I have assumed direction is right. I have assumed direction as what? Anti-clockwise direction. So anti-clockwise direction, assumed direction of MC is right. Then we will go for a third, that is parallel component at A and C. So what I have to do? I have to resolve this 25 Newton of force into a two parallel forces, one at A and one at C. So it's given over here. You can see that original system is same thing I have copy pasted here, and for a new I have assumed that FA, again assume direction upward, and FC, that is force at A and force at C in upward direction. Now I have to solve this third case. so that I can get value of FA and FC. Now to solve this, what we will do? Okay, so we will take moment about point A. What I'll do? I'll take moment about point A for both the things, for both the cases. Okay, so summation of moment of original system is equal to summation of moment of new system, but I'm taking about point A. Now why I'm saying this equal? Because again I have resolved this 25 Newton into the two forces, then its end effect should remain same. Okay, then here if I'm taking moment about A, then as earlier we have completed this part, it will give me moment as 25 into 2, that is 25 Newton of force acting at 2 meters away from the point about which I am taking moment, and it will produce moment in clockwise direction. So I have kept minus sign over here, is equal to, now for a new system I'll take moment about point A, so definitely FA will become 0. We are left with FC, then here we'll write FC into, what is distance between FC and A? Then it is what? 5 meters. Okay, and then you can see that it will produce moment in anti-clockwise direction, so I'll keep it plus. With this, can I say FC is equal to 25 into 2 upon 5? Okay, and then I have to put minus sign over here. Okay, and then by solving this I'll get answer of FC is equal to 10 Newton, and this minus sign, so here I'll get minus 10 Newton. Now here this negative sign indicates that my assumption is wrong. Why? Because I have assumed this in upward direction, FC, then I have assumed this in what? Upward direction. So this my upward direction is wrong. Then I'll say that FC of 10 Newton is acting in what? Downward direction. So that is my first answer of case 3. And then finally I have to find last part, that is FA. For FA I'll take moment about point C. Now I'll take moment about point C. Okay, so here I'll say first thing is summation of moment of original system about C is equal to summation of moment of new system. Okay, then here you can see that this is 25 into, now I'm taking moment about C, then this 25 Newton will produce moment in which direction? Clockwise direction, and it is at distance 3 meter. Then this 25 into 3, and I'll keep it what? Positive. Okay, is equal to summation of moment in new system. Now this time I'm taking moment about C, so FC will become 0, and this FA will come into the picture, and FA into, what is the distance? Then FA into 5, and now FA is producing moment in which direction? So it is producing in clockwise direction, so minus sign for clockwise direction. With this, can I say that FA is equal to 25 into 3 upon 5? Okay, and then this minus sign here, so I'll get value of FA as minus 15 Newton. Again this negative sign indicates what? That my assumption is wrong. And what I have assumed, so you can see here FA I have assumed it in upward direction, so my upward direction is wrong. And then finally I'll say that FA of 15 Newton is acting in what? Downward direction. So in this problem, what we have understood? We have understood that how to resolve a single force into a force and couple system, as well as how to resolve a single force into a two force system. Remember students that here sign convention is very important. Don't get confused between sign convention and assumption. Okay, so you have to put sign convention by default, but then whenever you are assuming any force, then definitely you should start with something. Then you can assume either upward or downward. You put that sign convention, and then when you are getting final answer as positive, then your assumption is right. When you are getting final answer as negative, then your assumption is wrong. I hope you have understood this sum. Thank you.